Okay, in this screencast, I want to talk through the binomial distribution. Now, we've done some work on the binomial before, and it was Pascal's triangle that we used to expand binomial expressions. If you remember, if we've got x plus 3 sort of to the power of 3, then we can use the binomial theorem, which centered around Pascal's triangle. Now, Pascal's triangle, I'll just remind you down here, goes like so, and each of these positions is represented by NCR. So this is the fourth row here. So this is the fifth row. So this position is 5, 0. Now, in between these two, I've got a 5, 1. In between these two is a 5, 2. Here's a 5, 3. 5, 4, and 5, 5. Now 5, 0 and 5, 5 are equal to 1. 5, 1 is equal to 5. 5, 4 is equal to 5. 5, 2 is equal to 4 plus 6. That'll be equal to 10. 5, 3. Now these buttons here are found on your calculator through menu 5, 3, and there's NCR. So if I want 5, 3, I hit like so, and it punches out the answer of 10. Now 5, 3 was that one there. 6 and 4 is 10. Now these, remember, were the coefficients in my expansion. So for x plus 3 cubed, I was accessing this row here. So my first coefficient was 1, and my power of x is 3, remember? So we go x cubed. My next coefficient is 3. Come on. Next coefficient is 3. My x power drops by 1. And my 3 now gets into the play by a power of 1. And then my next coefficient is also a 3. X drops by 1, and I times by 3 squared. My last coefficient is 1. I've now lost my x's, and it's 3 cubed. And so we'd go on, and this would be 9x squared. This would be 9 times 3 is 27x. Plus 27, and we've expanded. Okay, really useful when the powers are higher, and we could target certain things. But this was a binomial expansion. Now we're looking at the distribution, the binomial distribution. 3 tosses of a coin. Let's see how it relates. All right, there's some stuff here that I want you to write down, and there are 4 sort of conditions. These two are probably related, so maybe it's 3 conditions. Fixed number of trials, 2 possible outcomes is important. 2 possible outcomes. Now let's have a look. Heads, tail. We'll come back to some of that stuff as we get into some examples. Okay, number of heads is x. So when we're tossing the coin 3 times, we can have no heads, 1, 2, or 3. We're looking at the distribution, the probability distribution of this. And what I want to highlight here is I filled in all the probabilities, and you can check them. But let's just have a look at one head. See, one head turns up here, here, and here. So there's 3 outcomes that satisfy one head. There's also 3 outcomes that satisfy 2 heads and 1 head. Now look at that top row and tell me what you notice. 1, 3, 3, 1. We've just done something there, haven't we, with that? And so what we're going to do is we're going to use Pascal's triangle, Pascal's numbers, rows, whatever you want to call them. They're going to feature now in our calculations of probability, because what they do is they give us the number of combinations in, for instance, here, 1 head and 2 tails. When you're tossing a coin 3 times, 1 head and 2 tails, it can come down in 3 different ways. If you're tossing a coin 5 times, how many ways can we get 2 heads? Well, that would be 5C2. That'd come down. That'd be in here. So that's where the binomial, the Pascal's triangle, is going to assist us now in working through some binomial probabilities. And importantly, in binomial probabilities, there are 2 possible outcomes. Typically, it's a pass, fail, hit, and miss. We're going to have a look at an example in a moment of such a situation. There's a fixed number of trials. That's important too. There's 20 attempts, there's 10 attempts, whatever. And the probabilities are consistent from one to the next. They're independent of each other. Okay. So, for instance, let's now go down and have a look at an example. Okay, so in this example, we've got a multiple choice exam. There are 5 possible answers. A student guesses the answers to all 10 questions. So does this satisfy the conditions of a binomial distribution? There's a fixed number of trials. Yes, there are. There are 10 questions. There are two possible outcomes. Yes, there are. It's either right or wrong. So it's either a tick or a cross. So that is good. And the probabilities are constant from trial to trial. Yes, there's a 1 in 5 chance every single question. So this is a binomial probability scenario, and we're going to use the binomial theorem and Pascal's triangle to help us to look at different situations here. So, for instance, what is the probability of this student getting exactly 3 out of 10? So that could be one of the questions. So what we're looking at now, we've got 10 questions. How many ways are there of the student getting 3 out of 10? Now here's one of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's one way, but the student could get the first 3 wrong, the next 3. There's lots and lots of different ways. In fact, how many ways are there? There are 10 C3 ways of achieving 3 correct out of 10. Okay, there's that many. But what's the probability of each of those happening? Well, the probability of getting that one right is 1 in 5, or 0.2, and the probability of getting that one is wrong. The probability of getting a question wrong is 4/5, or 0.8. This one here is 0.2. Getting it wrong is 0.8. This one here is 0.2, and these are all going to be 0.8s. So what we've got here is 0.2 cubed times 0.8 to the power of, well, there's 7 left, isn't there? So that's the probability of getting 3 right and 7 wrong. Okay, but there are 10 C3 ways that can happen. So if we multiply these 0.2 cubed by 0.8 to the 7 by 10 C3, we will have the probability of this student getting exactly 3 questions correct. So let's go and look at this 0.2 cubed. Let's go and put this through the 0.2 to the power of 3. All right, that's in. I might pause this out. Okay, I punch the numbers in. 0.2 cubed by 0.8 to the power of 7. Remember, that's 3 right, 7 wrong, and 10 C3 ways of all that happening. Hit enter, and we get 0.201, 3 significant figures. 0.20, what was it? 0.201, right? So let's write that down, 0.201. Okay, so the probability in green here, I've just written it out in a sort of formal way, the probability of obtaining R successes from N trials in a binomial distribution. Let me just explain what this here is about. As I've written here, X, this means, you'll see this notation a little bit, and it says X is binomially distributed, so it just allows you to use the binomial distribution result, which I have here. N being the number of trials, and P being the probability of success. Okay, so in this case it would be B bracket 10 being the number of questions, and 0.2 being the probability. Okay, so this here is our, if you like, our formula to calculate the probability of R successes from N. So NCR, the probability of success to the power of R, which is what we've just done here. The probability of success was 0.2. The number of R being the number of successes. In this case, we're looking at 3 successes by 1 minus P, so 0.8 to the power of 7, S7 being N minus R times 10 to 3. I'll just put that the other way around. So let's do another example. What's the probability of 5 successes? So we would do for 5 successes, so e.g. Okay, so for 5 successes, we've got 10 trials, remember? So we go 10C5 in this case. The probability of success is 0.2 to the power of the number of successes, which is 5, and then it's 0.8 also to the power of 5. So we put that through our calculator. Okay, so here it is, 0.2 to the power of 5 by 0.8 to the power of 5 by 10C5. So hit enter on that. Should be quite low, 0.0264. 0.0264. 0.0264. So this is, remember, the probability of exactly 5 successes, and that's only 3% if you're going to guess every question. Understandably low. Okay, we can use the calculator to do this for us, and I'll show you how that's done now. So this is the sort of the manual method, and this will be this formula will be given to you, I'm pretty sure, in the formula booklet. But let's just go now to the to the calculator method. So we're going to go into menu from any page, go into probability 5, go into distributions 5. When you get to distributions, right, arrow down, D is binomial PDF. That's what we're looking at the moment, binomial PDF. In there you put the number of trials. This is dead easy. In the next window, it's the probability of success. In this case, it's 0.2. And let's calculate the X value. Now, if I don't put anything in there, it'll give me the whole distribution. It'll just give me the distribution of 0 successes right through. So I might just do that initially, and we'll have a look at what comes out. So you see that there's so 1 success, 2 successes, 3 successes, 4, and obviously those probabilities are going to get lower and lower. But if I go back now, escape out of that, perhaps I can't do that. I need to go back in there, menu again, 5, 5, and the letter was actually D, so you can punch in D and you get straight there. Now the number of trials again, we'll put in 10 there. The probability of success 0.2. Let's just put in our X value. So the number of successes we're interested in is 5. Hit OK, and what we'll get is 0.026, which is what we got here. So that's straight in. This is the manual method. The calculator will do it for you. What's going to be of interest to us often, though, is to find the probability of at least 5 successes. So we might want to say, what's the probability of actually passing this multiple choice exam? So I'll pause while we write that up. Okay, so here we've got a classic calculator exercise, because if we're going to do this manually, we want the probability of at least 5 successes. So we're going to take this, we're going to have 5 successes, and then we're going to add 6 successes. So it's going to be 10, 5, 0.2 to the power of 5, 0.8 to the power of 5, plus 6 successes, 10, 6, 0.2 to the power of 6, 0.8 to the power of 4, plus 10, 7. Right, you get where I'm going with this. 0.2 to the power of 7, 0.8 to the power of 3, all the way through to plus 10, 10, 0.2 to the power of 10 by 0.8 to the power of 0. I can leave that off. So that's a huge manual calculator exercise, but the calculator is going to do it for us, and I'll show you how. Go back in, hit menu, 5 and 5 again, 5 and 5 for distributions. But now instead of hitting D for binomial PDF, we're going to hit E for binomial CDF. Right, now what you'll notice here, we've still got not 10 trials, goes in there. The probability of success is still 0.2. But now we've got a lower bound and an upper bound. Our lower bound is 5. Trying to get that in there. Lower bound of 5. And our upper bound is 10. So that's inclusive. Lower bound 5, upper bound 10. This is what it's going to do is going to add all those up. Hit OK. Yeah, there we go. It's 0.0264. So what that means is that the probability, that's still a PDF. What's going on here? Pause. Okay, not sure what happened with my calculator there, but you can see now the binomial CDF, which is what we've done, is we're having a look at 10 trials, 0.2 being the probability of success. Our lower bound and our upper bound are there. So what that does is it sums up all those probabilities that I had written down before. It's now 0.0328. 0.0328. So we can write in here 0.0328. That is the sum of all those, and it's a calculator exercise. It's menu 5, 5, and then you hit E and you put in your lower and upper bound, and it will calculate it for you. Okay, I think that's probably enough, and I reckon you'd be right to go now with exercise 15C. So we'll get stuck into that in the next lesson. I'll see you then.